Yo, yo. All right, we're here. We're here. I don't know what was going on, but I had to shut it down real quick. I didn't get no dang water. So that means at some point I'm abruptly gonna have to walk away and get some more water. These are the trials and tribulations of streaming. But we built for it. We were ready for this. We were molded by this. I don't know if any of my little sound things were even set up. Nope. So half of them were set up. So that's good. Wait. No, that's not set up. So that means these aren't set up either. Damn. Set up? Yeah, that's set up. Alright, so the Kevin. We'll probably use the other ones interchangeably. Let's see if Clip It works. Oh. Okay, so that works. What about the shout out feature? TH. Let's see. Alright. The new update. Whenever Streamlab put out a new update, you just know something's not going to work the way you need it to work. But we'll work through the kinks. Doesn't look like too much of a lag on the stream. And I'm running at green bars. So we'll get into the main focus of today, which is learning. Have my chat box clear? Clap it. Okay. The goal is for us to be able to get some more programming done, obviously. Hopefully we can get the main man Danny, get him on and have him talk about some of the more interesting aspects of the coding language and things of that nature. So we'll work through it. Super laggy. All right. Let's see. Shout out feature. All right, yeah, okay. That's cool. So that works. So those are some things I added to the stream to upgrade it. 12-second clip whenever I want to shout somebody out. The goal is to maintain 3 viewers concurrently because we're at 2.7 viewers. So this might be the day. we're working on Python today. So we'll keep pushing with the Python. Let's see if I can host. Shout out to the 3. I don't know what happened. Did that even work? Doesn't look like it worked. That's tragic. Anyway. Alright, let's get into it, shall we? Boom. So we were watching a ton of videos on here. So we have this set up. So let's get our other prompts set up. Let's get our virtual studio up. Or VS Studio, actually. VS Studio. And then we get our command prompt up. Alright, command prompts up. I'm a little tired. Tweaked the most proximal part of my tricep at the apical center. So that kind of hurt a little bit. And we're just sharing this with the group. Sharing it with a few. Because I've made up my mind that I gotta build a new PC. So I've come to that conclusion. Building a new PC. Who we want dancing today? Painting at the house. Fat Mac is painting at the house, everybody. He is painting at the house. Clap it up for painting at the house. And T Boy has forgotten his login. So there's that. It's just further proof that, you know, we all got something going on, right? Oh yeah, Art. We've stepped it up. We have stepped it up. That's the goal. Hopefully, I don't know if Danny's free tonight, but I kind of want to get this part done. Let's see. Let's jump on the Discord real quick, shall we? Let's jump on the Discord real quick, because if I can get the virtual studio up the way I want it, then I can like definitely edit out a lot of this extra stuff. But thanks for joining the stream, Art. Clap it up for Art. Drop a bomb.
Damn.
Old roommates. Talked me into buying not a new PC. He talked me out of buying a new PC. He said, you know what? Why don't you just do the same thing and build that shit? And you're right. You sure enough. So we're gonna build our PC. And once we get this channel affiliated, as long as we got 4 people watching, I think we could do it tonight. Tonight might be the night. So even if you can't stick around, just keep me going on in the background. That's the great thing about Twitch. It lets you keep stuff on the background. And it looks like we're holding in there. Center to screen. All right, cool. All right, let's see what the Discord got. Because I found out painfully today that I would not be able to update my RAM, and that's really what's been kicking my ass, you know? Not being able to update my RAM has really been hurting. So I have to and then I was gonna go ahead and okay, you know, and when you first run into an issue, the next immediate thing, okay, what would let me hold more RAM? All right, you need a new motherboard. Cool. What's a good motherboard gonna cost me? $500? All right, still less than $2,000. So let's do that. And you go down the rabbit hole. Danny is on. Let me see. I am on now. You are free. So we'll get the terminal fixed. Let's see if Danny's available. If not, we'll push on. And we'll basically, and what we always like to do whenever we come back. So as we wait for a response on that, we'll just start off here. So, you know, we got the Python in the terminal. So we put in Python into the terminal. I know that's kind of hard to read. Hopefully the goal is to, let me actually, would that help? Nope. We good. All right. I actually want to restore this and try again. Transformation reset. Whoops. So we're gonna just practice run all the programs we have running right now. And that's just like my refresher to let me know what I have to do next and like what part comes next, what am I supposed to be doing. It just keeps things fresh in my memory. Mic check 1. Give me my control of my command prompt. Whoops. I'm moving my whole screen. Super intuitive. So let's lock all of this real quick so we're not shaking my whole screen. All right, so this is the part I actually want. So this was my first if-else conversation. Now I've done this twice, the if-else conversation twice. I've done it on a very elementary level, and then I added like a nuance level that I did with a few friends while I was on stream. But this is gonna then integrate into another like bigger issue. So it's like super important that I'm like always revisiting it, and this is my chance to like study and practice on it, because I don't want to be studying and practicing if that makes sense, like when people are trying to help me, because then I'm not like using my resources effectively. All right, so we got this terminal here, so we're gonna go with the cd. Where are we? No, that's syntax. So dir built-in function. Okay. Can we go desktop? Nope, don't need that. So desktop. And this is the part where I always get like stuck. So as soon as I'm here, so I can go cd change directory desktop, and now desktop has been added to it. So Is that, will that always work for me? So let's go CLS. But it takes me back to the last thing. If I hit tab, it'll show me everything in that change directory. So I can then go here and I'm looking for Python code. And then I can do a dir and it'll let me know everything that's going on in there or everything that's going on the desktop. Let's go change directory to space. We're looking for, there it is, Python code. And now Python code's been in. So then I can hit this with a dir and it'll let me know everything that's in there. Now, if I want to run any of these codes, let's hit the overtime, Control S on there. So I remember for this one, if you want to run the overtime, you gotta type the word Python. Overtime.py. And then the program should run. And as you can see there, it's asking me to enter the hours. And this is a if else statement. So let's do the latter. Let's go 100 hours at a rate of $5. So my overtime would be 150, but my pay rate would be 500. And the code is ready for me to start again. And then let's take the immediate, which would be 100 hours. Rather, it would have to be less than 100 hours. Is there a way I can go back? Nope. So we'll just do another 5 or 6. All right, cool. Let's do it one more time. 39 hours at a rate of 5. And there is no overtime. You just get regular pay. So it's calculated. So this is my wage calculator. I've done that, right? Then we have example 1, so we can hit this one. I just like to test this to make sure they all work. This is gonna be Python. Example 1.py. Enter name. Heero. Hello, stranger. Heero. So it completes my sentence out for me. So that's ultimately what we want to do. Is just make sure that all of these syntax we've made work. And it looks like they are. But, let me try to see if I can get this one a little bigger. Because it looks like we're only using this much of the screen actually. Big whipping. Big whipping. It's that big shit. Oops. And then we'll get into the program after this. I thought Danny was on, but he might be tied up right now, so we gotta push forward. And we'll get started with today's lesson. All right, cool. All right, so all of that's working. It's that big shit. Oh, that's the sound. Okay, here we go. And then we'll try and get this going here. We'll get the lessons. We're on lesson, I believe, 9. It's definitely taking me longer to work through these lessons. And I don't even think it's from a skill standpoint. It's just so much more information. And it's a lot more engaging than CSS. I will say that. Like, CSS has a lot of colors and stuff that'll keep you engaged, and they'll show you rewards. They'll let you use a lot of cool tools. You don't get to use the cool stuff here until you pass a few recommended lessons. So we're gonna try and speed course this. All right, so we are Python functions. Where are my notes? We are talking about the shit. Today is 1/12. We got 1/12/2022. All right. Before we start this, let me go get a functioning pen. What up, T-boy? I see you. Thanks for joining the stream. We got that. Yeah, we got that big cheese. Hey. All right, let's do this, party people.
Hello and welcome to Chapter 4, Functions. This is the fourth of our basic patterns. We'll get to iterations next. Functions is the store and reuse. One of the things in programming is that we never like to repeat ourselves. We don't like to, if we have 4 or 5 lines of code and we're going to do the same thing later, we don't like to put the same 4 lines of code in, even if it has to do with reliability. If you find something wrong with those 4 lines of code and you got them 12 different places in your program, then you got to find all 12 places and fix them. So we're like, collect those to one place and then call them and reuse them. And that's the idea of store and reuse. So this is how functions work inside of Python. The first thing we notice is there is a new keyword def that stands for define function. And the def is like an if statement, or we'll see fors and whiles, that they end in a colon, and then they have an indented block, and then the indented block de-indents, and that's the end of the function. And so there's 2 statements make up this function. The key thing that you have to understand and get used to is this def part is actually not running any code whatsoever. It's actually remembering the code, and that's what I call the store phase. The def creates a bit of code and records it like a macro, although it's much more complex than a macro, and it names it whatever you chose. You gave it a name. We named this one thing, and so it, like as a side effect of Python reading or parsing these 3 lines, it doesn't do anything, but it remembers. These 2 lines are what you would like to run when you invoke thing. So this is the definition of a function, and this is the invoking of the function. But so this doesn't do anything. So there's no output here from that stuff right there. But then what happens is you invoke it. And this thing looks like it's part of Python, but you in effect have extended Python with your def statement. And so when it sees thing, it goes up and runs your code. And so out comes hello fun. And then it comes back and goes to the next line, does print, so print comes out, and then it goes back and like, oh, this is the reuse part, but we get to reuse it. We define it once and we use it twice. Then it runs this code again, and then goes to the next line, and it's all done. So this little bit came out twice. And of course, this is really simple so that I can fit it on a page, but you get the idea that I don't want to repeat. This might be, 15 to 100 lines of code, and I don't want to type those over and over again. So I say, hey, store these in a name that I choose, and then when I invoke them, bring them back and then run them again.
Pretty cool.
Okay? So that's the basic idea. We actually have already been using functions from the beginning. The print is a function, right? Print is a function. Every time we see print, P-R-I-N-T, parenthesis, and then we have some stuff in here, we are calling the print function. This is the syntax with two little parentheses, is the syntax for functions. And so input's a function, type is a function, float's a function, int's a function. All these things are built-in functions that come with Python at the moment that we started. I mean, we installed Python and these came along. And then there's other functions that we define and use, and that's what the def is for. And in effect, we can create new reserved words of our own making that extend the Python language after we define the function. So it's just this bit of reusable code that takes some arguments. We haven't seen any with arguments. There's a little parenthesis, and we'll see how that works in a bit. We define using the def keyword, and then we invoke it. There's the defining phase, which actually doesn't run the code, it just remembers the code, and then there's the invoking phase. You define it once and then invoke it one or more times. Calling the function or invoking the function, we think of those two things as the same thing. Call, invoke are just the terms we use. Most people just say call the function, but invoking it is a perhaps more descriptive way to think about it. So here's an example of a function. It is built into Python. It's called the max function. And we can pass some parameters into the max function. So we pass the hello world string. Now, like much of Python, max knows what kind of thing is being passed into it, and it knows that it's looking for the largest character, the lexicographically largest character, and in this case, it scans this little, that's inside the max code, it scans through and finds the largest character. So apparently, lowercase letters are higher than uppercase letters because in English, we get back a W. And so this is what's called the return value. So this is an assignment statement. Let me clear this and start over. So this is an assignment statement, so it has to evaluate this right-hand side, and a function call is nothing more than like x plus 1. It's something to evaluate. It runs the function code, passes in this argument, and then this residual value, this is called the return value, we'll look at this in more detail, becomes the result of this little bit in the expression, and there's nothing else. We could have, W plus 1 or something, and then the W is what's stored into big. Okay, so we print big, and big is a variable that has the letter W inside of it. And then we ask what is the smallest, and that finds the blank, and so we get a blank to see this. There's a min function and a max function. Both of these are built in. These are built-in functions. They're always there for us.
It's that big
okay.
shit.
So here is another example of the max function, and so we can think of this as invoking or calling this function as this right-hand side is being evaluated. We are passing this variable in, and there's some code in here, and it's going to do some stuff, yada, 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 and then it's going to give us back a bit of stuff, and that's its return value, and then that goes up into the big, right? And so that's how this works. And so this is actually built in or burnt in, I guess I can't draw. And so you can think of this as sometime a long time ago when Python was being first formed, somebody wrote some code. And it's got some stuff in it. It's got a little loop that reads through all the letters. It has to figure out if it's a string or a list, etc., etc., etc. But this is store, except you didn't do the storing because it's already built in. And then this is the reuse, store and reuse. So we build these things into Python. They're already pre-built, as if before the first line of your code executes, way up here, someone put all this code in for you into Python and created a thing called max for you. Now we've been using this already, built-in functions, we've got type conversions, we've got like the float that takes a integer and returns a floating point version of that. And again, this is kind of like an expression. So it's like, I want to divide this by 100, but before I do that, I've got to convert it to a float. So it has to sort of do these function calls as it's evaluating the expression.
So this is
okay.
The functions.
Sometimes, like here, we just have a prints out the return value. That's what this is. This is the return value. If you just type a function in a parameter, it can be in a constant or it can be a variable. And as we'll see in a second, we'll give you many of these if you like. So you can either just run it or take the result of this. This passes an integer in, converts it to a float, and then puts the float into that. Type tells us what kind of thing that is, and you can use this inside of an expression. And so it's like, what am I going to do first? Oh, I've got to do 2 times this thing. Oh, wait a sec. Pause just briefly for a moment to call out to some float code, pass a 3 into it, and then something comes back, the return value, the residual value comes back, and then that participates. In this case, it's going to be 3.0, participates in this 2 times 3.0. Okay? And so 2 times 3.0 then ends up being 6.0, et cetera, et cetera. But you can see as it's like, oh, wait a sec, I got to figure out what this is, call the function, get the return value, and then continue processing this expression. We've also done this with string conversions, partly because, just as an example, the input always returns a string. The input function returns a string. And so, here's this string, could be coming from input, but we'll just take 1, 2, 3. We know that that's a string. It's not the number 123. No. And if we try to add 1 to it, we get a trace back. Yep. Cannot concatenate string and integer.
Move the 1.
Trace back. But we can convert that string to an integer. And so int can take like a floating point number or an integer or even a string, and it says, oh, I know what I'm supposed to do with a string. I'm supposed to look at this, interpret these as numbers, and, multiply by 10 and figure out what the hundreds place is and all that stuff. There's a little bit of work to that, and it does it. But then it gives us back an integer, and we say, oh, what is that? That's now the 123, but it is of type int. And now we can add 1 to it and get 124. Mm-hmm. And as before from this example that we're kind of reusing from a previous chapter, you don't want to try to convert, oops, sad face, sad face. Sad face. Don't want to try to convert something that doesn't have digits using int, because it'll say, I don't know what to do, and then your program quits, right? You don't want your program to stop, tracebacks, and you can, of course, deal with that with try and accept, but that's like a previous lecture. Okay, so up next we're going to talk about building our own functions, not just using the predefined ones.
Oh, shit. You make your own functions? So now we're talking. Alright, so then let's just look at this question. So we know the definition, right, of a dev, the purpose of a dev. It's to store information. That's the basis of it. So I'm going to skip the first 2 because they seem wrong off top. It indicates the following indented section. That seems wrong. It's not none of the above. I'm going to go with this one. I was right. Clap it up. Drop a bomb. That boy good. But we gotta exercise. So we will get to write code today. So we do have an exercise. What was the other code that I was writing before I did this one? I never finished that code. So let's look at Virtual Studio. Because if we didn't finish that one code, we can go back and do it. Yeah, we actually did it. Shout out to the 7 people watching with me. We're gonna get affiliated today. We're gonna get affiliated today. Believe in it. If you want to watch, please watch here. We're gonna get affiliated today, and it's because of y'all. I believe it was variable expressions, conditional executions. So, no, it wasn't this one. Nope. Nope. So we're gonna quickly run through these. Try and put eyes on the one that. Okay, this one has exercise. This one doesn't. This one does. This one doesn't. So let's start here. And we're just trying to make sure we know what the exercise is asking us. I've already done this one. So this is the exercise.
Silly here where I put this print statement in, and it's so tempting for a programmer to just immediately try to, like, bam, finish it. And I don't know why I did it this way. Maybe because I know that I'm flawed and I know that I make dumb mistakes like that. And what can I do? So I was just being really careful there. Now I know, let's just be sure, if it's under 40 hours, it's going to be a regular computation.
No, we did this.
And I'm going to leave these print statements right in here for a while because whatever. So it's a real common thing for a programmer, and you can look on GitHub and see code that I write, and I just leave these in because, you know, that could be broken, but right. You're not supposed to print.
Let's go back. Hey, gentle.
Hello, everyone, and welcome to Python for Everybody. I'm Charles Severance.
Clap it up for
immediately try to, like, bam, finish it. And I don't know why I did it this way. Maybe because I know that I'm flawed and I know that I make dumb mistakes like that.
So
and what can I?
Oh, we won't get Danny till 11. 30, which is tragic, but you know, the show got to go. The show's got to go. I think they have the same plugin because I'm going back and forth, honestly.
Hello, welcome to Python for Everybody. I'm just nervous enough to want to double check this. And so I will do something like this. I will say XYZ pay and save it. So I'm in this EX0301, so I'm going to use a command, and you can use this both in Windows and in Linux and in Mac, cd ... And what that does is that goes up a folder. Part of the goal of this course is to teach you how to use things like this, just how to use these command lines, because to be a programmer, even doing the simplest stuff, you got to manipulate files and you got to be able to use command line, you got to use all these things. Not everything is a full screen clickety-pointedy thing, okay? And so what does CD do? Well, it looks at this and it goes up one folder. So it moved us up into here. And so you can see after the CD, my current working directory is that, and I can do ls to see the folders. And now I see my new EX0302. So say CD EX0302. And part of being a programmer is having a lot of folders with weird names to organize your stuff, ls. And so here we go. Now we have this file and this file in the same place, pwd. This matches this, that file matches this name, and I can say python3 ex0302.py 1010. Okay, so now I'm just nervous enough to want to double check this, and so I will do something like this. I will say XYZ pay and save it and then run it again. Python3, I don't care about the numbers. See the XYZ pay? So now I know I'm in that file. So I do stuff like this all the time to triple check that I'm really working with the file. So now I'm in this file, and now let me make my mistake again, 10, 10. And now there's my failure, right? So there's the mistake, and that's the thing we got to fix. So we have these lines of code. So what you do in Python, when you know that there's a dangerous set of lines and you want to take out insurance on those, you put them in a try-catch block or try-except block. And what are we supposed to say when it blows up? It says, error, please enter numeric input. I'll just copy that and paste this. Print, error, please enter numeric input. Make that a little bit wider. Print that out. And I want to put this print statement back in. Okay. So here we go. So now what's going to happen is we're going to come in here. We're going to run these. If they work, we'll skip the except block and continue. If they blow up.
So I want to actually, so I don't get too far left behind. I want to give it a shot. Oh, we got 9 people watching. What's up? What's up, you suckers? Clap it up for those 9 people. Drop a bomb. Alright, so let's take a look at the code that we're going to use in question. So we're probably going to end up using this one doesn't have an if else, so we can use the original. I have an if else statement here. So this one will work in tandem. So what did he say, right? The fear is, so let's demonstrate the fear. Let's see if the fear works actually. So let's go, we're in the black box now. Let's go Python and we're doing overtime. Overtime.py. All right, the code works. So let's say 100 hours. 100 hours. Enter, and let's say the enter here for rate, we say 10. The error, we get an error. We get a value error. So basically, it doesn't understand the word 10, and that ruins the code for us. That's the end of the code. But with this try method that we're about to do, so let's go up here. I believe he put it between, yeah, because we want these to be numbers. So we're gonna go enter. We're gonna hit try. So we need a tab there, right? Whoops. So let's hit a tab here. Try. Whoops. And we want these to be in here with the accept. So, and what did he exactly write? Look at us guys, we're doing it. Let's see what he wrote. And then we go the accept. If this doesn't work, if something happens to these, we'll do an accept and say error, please print numeric value. Okay, so we now know what we got to write. We'll say accept print parentheses, and this isn't a value, so the parentheses will make it just text. Error, please enter numeric. Is that how you spell numeric? Input. Numeric value. All right, let's see what we get. Well, okay, so we now have this. So we're at least caught up to speed with him. So, and just a refresher, we have this stuff up here is our inputs, our original inputs. These flow rates define our inputs. Then we have those defined inputs in their try and accept portfolios. And then we have an if statement. If you made over 40 hours, if you worked over 40 hours, you'll get print overtime, which is a statement. And the calculations for that statement is reg equals FRT times flow, overtime being that, times the 0.5 rate. I'm happy to be your teacher. I'm happy to be your teacher. Are you gonna bring me an apple though? That's what you really want to know. Clap it up for healthy living. Clap it up for healthy living. I'm gonna go to my my other account because I have way better sounds over there, and I want to use those sounds. It took me like 6 minutes to download all those sounds, and I don't even have access to them. It's crazy. Like I got these great sounds. Like who doesn't love a bing bong? You feel me? Who doesn't love this one?
Beta!
That's just funny to me. Aggressive. Are there any questions out there?
Would you like to answer a question right at this particular time? Would you like to do that?
If you have any questions, feel free to ask. I'm new, you're new, but there's 8 people watching, so I feel like there should be more questions. All right, let's save this. And then let's head back to the video, shall we? So we can then get it back up to speed.
Then it's going to run this except block. So let's run it. Let's start with a working case. That still works. That's good. It comes and does this extra print that I've got on line 9. Let's go in the bad case. 10, 10. Okay, so we got to parse this a little bit. So it says error, please enter numeric input, but then I still get a traceback. And you're like, I hate computers because doesn't this look beautiful? I got to try and indent it. It looks just like what I saw, right? It's so beautiful. Why does this computer hate me so badly? Well, then take a step back and say, you know what? The computer is admitting that it's confused by what you've given it.
You've got to trace
and so just look, what line are you mad about, dear computer? Line 9. Okay, let's take a look at line 9. It's always this line or the one before it, almost always. Almost always it gets it right. And it says name FR is not defined.
Oh.
So that, just focus on this. It's complaining about this.
But FR is defined.
And the problem is that it came down here, it ran through here, ran through here, and
Clean
this blew
Star,
up.
What's
That
up?
line
Thanks
never
for joining
ran.
the stream.
That's the line that blew
Happy
up,
to
and then it
have
ran
you.
this error. So it never got a variable or a value
How's
in
your night
FR.
going?
And that's because in this particular case, we would either have to put an if statement in to make sure the rest of this code, or we can say, you know, if everything is just so bad in this thing and I don't want to continue, quit basically says do not continue. Okay? So when it comes in here, it runs this, it blows up, it comes down to here, it prints this, and then it quits, and then it doesn't continue on. So now I can run this again, 10, 10, it works, 10, and TEN, and it fails exactly the same way. This part here is exactly the same as this part here. The difference was, as soon as we print this out, we quit so we don't continue on. Okay? So if you're doing really simple sort of input checking, sanity checking is one of the things we call this. We're just,
So that's a great tool, actually. Shout out to all the people that followed the stream. I appreciate you guys. These are some people from last night. So another thing you have to instruct it to do is actually quit, because once it does is accept and has completed this error, it'll push forward because it did skip this, but you do want it to like kind of stop. So I guess that's a good point of reference. Let's go. So then let's add into it. So we'll be just right here. But okay. Well, it makes sense. Oh, quit is its own function. I gotta stop doing that. Every time I hit quit, it gives me an arrow. All right, so this should work. So let's go ahead and give it a run. We can just hit up because that was the last thing we ran. Enter hours, we'll say 100. Enter rate, we'll say 10. And it says error, please. I didn't spell enter right. Enter, Control S. Let's run it again. Oops. Control S. So let's come back here. Let's run this numeric code one more time. Enter hours 100. Enter rate, we're gonna say 10. And it says error, please enter numeric value. And that's the code. It's a fail safe. Like it'll start again. Okay. So I fucks with this.
Does the data make sense? And don't continue. If the data doesn't make sense, if these two statements don't work, then whatever we've been given is nonsensical data that we're not capable of handling. Okay? So that is how to write exercise 3.2.
Your own magazine, so I can watch
I
you.
hope that you have found this little video useful, and thanks for watching.
Strong work, my guy. All right, let's go to the next one. Break. Give me a second. All right, next one. Oh man, it looks like things are getting a little bit intense. What will the following Python program print out? That's actually that's an interesting question because I don't know. Just looking at this is the first time I've looked at the questions and couldn't guess the answer. All right, let's hear what he's got to say.
So welcome back. We're going to continue and start talking about building our own functions. So again, we use the def keyword to define a function, and then later we're going to invoke this. And there's a bit to it. We are defining the name of the function. In effect, we're extending Python and creating new predefined things that we can use, except it's our code. It starts with a def keyword, has some optional arguments, which we'll see in a bit. That's what the parenthesis is. And then the name. And the function names follow the same rules as variable names. And then you have an indented block, whatever code you want to do, and then you have a de-indented block, and that sort of defines the essence. The key thing here is this is not calling. It's not invoking. It's not executing. It's remembering. It's storing. It's figuring things out. So here is the output of a program that defines a function but then doesn't use it. So this is a sort of broken function. So here we go. We start x equals 5, print. You don't have to you have all the defs at the beginning. The def runs whenever. So, out comes hello. And then we define a function, and this says, oh, you want to make a new thing here. So I'll make a new thing. It's kind of like a variable in a sense. And then it copies this stuff, copies it up there, and says, later you probably are going to want to use this, so I'm going to remember it. So it doesn't do anything there. No output comes out. Then it says print yo, and out comes yo. And then it adds 2 to x, so x is now 7, and then it prints x, and there's no 7. There's 7. These print statements never ran. They never ran. Why? Because we did not invoke them down here. We defined them, but didn't invoke them. So let's take a look at how you invoke a function, right? You define it, and then you use it. Sometimes you define it once and use it once, but more commonly you define it once and use more than one time. Again, the store and reuse pattern. The def is the store, and the invoking is the reuse.
Okay.
So here's just a slightly different version of that last program, and so now it's going to actually invoke it. So x equals 5, print hello, def, so out comes hello. This produces, the def produces no output, right? But because there's a de-indent here, that is the entire blob of the code that is part of print lyrics. So it prints out yo, and now we're going to invoke. This is the call. We're going to call the function. Now the function goes up. Let's clear this. So we're down to here. Now this like suspends at this place. It's like remember to come back to here when we're done. Go up, run this code, and then come back, and then continue on. So it like leaves like a breadcrumb of where it's supposed to come back to, and then it runs, and then the print lyrics, of course, produces the 2 lines of output, and yeah, that should probably not have. That day should be up there, and then x equals x plus 2, which makes it 7, and then prints out 7. Okay, so this is the invoke or call the function. Okay, you defined it, and then later you called it. Now, in addition to just call and return and invoking, we can pass parameters in. And the example of the parameter is in the max function, we have to say, this is the thing I want you to find the maximum of, the largest thing. And part of it is in the whole store and reuse pattern, we have a few lines of code, but sometimes we want to do ever so slightly different things in the different invocations. And so we use the arguments to subtly adjust, like finding the maximum is a general thing, but what thing to find the maximum of, that makes a function that's much more useful and reusable in a lot more situations. So arguments are the thing we passed in, and we define for our functions that we're going to build, we, on the def statement, so we say def, greet, name a function, and then this is the arguments, the things that are coming in. Now, this lang variable, in a sense, only exists during the life of the function, and it represents sort of a placeholder. It's not a real variable in the same sense. It's a placeholder that refers to how you touch that first parameter that's sitting in there. Okay, and so lang is our first parameter, whatever it is. We don't need to see this part down here right now. All we know is we're going to make a function, and we're going to take a parameter, and this lang is the placeholder that tells us what that parameter is. Okay, so within the function, we're going to check to see if the language is Spanish. If we are, print hello. Else, if the language is French, print bonjour. Otherwise, print hello. We have a very highly simplified language translation system here. So the def, of course, does nothing except remembers that and defines the concept greet. So that comes down, and now we're going to call it. And that says, go look up the thing that I defined called greet. If you don't put this in, greet is going to give you a traceback. But because you extended and named it greet, so it runs in, it starts, suspends the code here, starts up here, but then lang is now an alias to en. So now we can run if that is yes, else if, I'm getting it all wrong now. Right, so en comes in as lang, we're coming in the code. If it's not es, it's not fr, else it prints hello, and then it comes back to the next line. And then we call it again, and this time es is lang, and so it runs this code and prints hola, and then next time it calls with this, and then it prints bonjour. You get the idea. So this is a placeholder so that on the successive calls or invocation of the function, we can get at whatever the programmer put in as that first parameter. And so we are saying in this definition, we are ready to receive a first parameter. Please call us with a parameter, and then we will be able to do something slightly different for the different values. So this is a reusable bit of function that prints hello in 3 different languages, and then we tell it what language at the moment that we're actually invoking it. So that's putting stuff into the function. Now getting stuff back out is the concept of returning. In the return statement is an executable statement that does 2 basic things. The first thing that it does is it finishes. Now this is a one-line function, so that's kind of redundant, but when Python goes into the return statement, it doesn't continue on to the next line. It just returns. That is the end of the invocation of that particular function. But even more importantly, it takes as its parameter. You can say return without a parameter, and it will stop the execution of the function, kind of like a break does for a loop. It's kind of a break for a loop. Get out, we're done. Don't run that next line. Get out. But it also allows the specification of what you want as the residual value in an expression. So we're doing a print, and then we're saying greet. And what's going to show up here is whatever this function does in its return statement. And so that prints hello. We call it again, and it prints hello again. Okay? And so basically the return statement is I call this the residual value. It's like what shows up here when the function is all done, and it's the string hello. We call the functions that return values fruitful because they produce something, and but you don't have to. You can just say return, or you don't even have to have a return statement. It goes to the last line of the function, and it does a return automatically at the last line of the function. So here's a little bit of a rewrite of our little language program. We are going to create a greeting program. We're going to take the language as the first parameter. And instead of just doing a print statement, which is what we did before, this is now more like a function because it takes some input and produces some output as a return rather than just printing. It's a little tacky for a function to print. And so here we return hola, bonjour, and hello based on the right thing. So now we say print greet en, so it runs the code once, lang is en, and then it runs this code, and the residual value is hello, so it says hello Glenn. And similarly, when it runs this code, it passes es in as lang, it runs through, and it runs this statement. It does, if there was more statements, it wouldn't run them. As soon as this return runs, that says that this bit right here is now HOLA. So hola Sally. And the same with French. Goes in, runs again, out comes the return statement, and then bonjour Michael. So you see how we can control as we're writing the application, we can control as we're writing the function what the residual value that we want to see in whatever expression is calling us. Sometimes we have returns and sometimes we don't have returns. So if you think of the max code that we talked about before, we can kind of see that somewhere inside that max code there's a return, and that's how it communicates the W back to us. So we pass in as argument, hello world. It comes in as a parameter, and it's going to loop through this imp somewhere. It's going to loop over and over into imp, and then at some point it's going to figure something out and tell us what it wants to send back to us is a return statement, and so the W comes back and gets assigned into big. You can have more than one parameter, and they're just in order. The first one and the second one, 3 and 5. So 3 becomes A and 5 becomes B, and away we go. So we just use this to add two numbers, and so 3 plus 5 is 8. So you get as many as you like, and the order matters. And if you do things like you tell it you want parameters and you don't give it to them, then that'll become a traceback, and it'll blow up. You can also talk about optional parameters later. So you don't have to have return values, and that means that you simply don't call a return with a value, and return is always implicitly happening as the last line of the function. So that's kind of the basics of how functions operate.
I'm not even gonna lie, this is probably the first time
I don't want you to get too excited about writing functions. Some programming classes are like, gotta write a function, gotta write a function. Functions, to be clear, are a very powerful mechanism. And as we write programs, 150, 200,000, 200 lines of code, 1,000 lines of code, 10,000 lines of code, the concept of a function is really important. We would go crazy if we didn't have functions. But if you're only writing 20 lines of code, forcing yourself to write a function is kind of pointless. So don't worry about maybe the lack of urge to use this. We are calling lots of predefined functions, and we will for the next couple of lectures. There will be a time when you go like, oh, I'm sick and tired of repeating myself. Oh yeah, time to write a function. So that's why we don't push functions prematurely. We just want you to know what they are, use them, and at some moment you'll be like, oh, I want to define one. But don't worry about, it might take a while before you really want to define a function. So that kind of summarizes our lecture on functions, and up next we're going to do iterations.
Very cool. How much time I got left? 15 minutes? Let's try the exercise. Ten-minute video.
Hello and welcome to Python for Everybody. This is another of our worked examples, and I'm your instructor, Charles Severance. So the example we're going to do right now is exercise 4.6 in chapter 4. This is an exercise where we're kind of taking code that we've already written and redoing it in a way to just prove that we can do it with a function. So it's not like it's going to do anything different. It's going to do exactly the same as before.
Since we're
just going to do it a different way. So let's go ahead and start up our text editor, Atom. Show you a couple new features of this. It's already been opened. Let me sort of open it here again. I'm going to open.
We're going to come over here. Make me fight you.
Get a new window, and then I'm going to.
Yeah. I'm literally about to do what he's about to do, which is. Oh, do I already have one? So, let's see how much he does take. Hold on. Let's see how much he does take. He done. And then we'll play some Call of Duty if T's still on.
To open, but what I'm going to do is to open this folder, right? So it's this folder right here, and I'm going to open that. So instead of opening a file, which is what I've been doing so far, I'm going to open a folder. So now you can see all the folders that I have, and they're just exactly the same folders that I've been making under desktop py4e. And so I can go and look at my previous assignments. The other thing I can do is I can control click on this and say new folder. And I can say EX exercise 04, 06. Again, I like the 04 and the 06 just so things line up when we get to chapters 10 and 11. That's why I'm naming my files this way. And I'm going to adapt exercise, the code from exercise 3.1. We could do exercise 3.2, but it's longer. The difference between 3.1 and 3.2 was one uses try except and the other one does not. So I'm going to try to start with this one. I always clean up and get rid of that. So here is our time and a half for overtime logic. And I am going to say file save as. So I'm making a copy of it. And I am going to put this in this folder exercise 4.6, and I'm going to make sure to rename my file 0406. Okay, so now I've got exercise 0406, which is this one right here. That's the file we've got, and it's there. And so let me pop up my terminal window.
Share this with somebody,
CD
guys.
desktop, CD py4e.
Oh yeah!
CD EX04. Hit the tab for 06 because there was only one in 04. And so I can see where I'm at. I have one file here, ls. And this L gives extended information. And I can say Python 3 EX04 py 10 10, and away we go. Okay? So this is this code. I'm going to get rid of some of this logic here. Just these print statements, which I commented out, just to make it a little more dense. Okay, so let me start by just putting a function in here. And of course, def is the keyword for function, and compute pay is the name of the function, and it's supposed to take two parameters, hours and rate. And then you add a colon, and then we're indented, right? So the indent is to determine how long the function it lasts, how many lines it is. And I'm just going to say print in compute pay. Give myself a blank line.
Yeah, so he did yeah, let's make a new one real quick. Let's make a new one real quick. We can use the so let's use this one. we can put it into here. And then we can get rid of the accepts. We can get rid of all of this actually. And then we can get rid of the try. And hit control save. So now we'll be running example 3. So that means we got to go back to our terminal. Make sure we're in the right place, right? So we're not, so let's hit this. Let's go Python example _3 .py. That was long and unnecessary for no reason. Let's say $100. One. Alright, cool. Let's run it again. Oops. $20. Interesting. Let's run it one more time. $14. Alright, cool. So we know the code works. We know the code works. So that's all I'm doing is just make sure that this code that I just wrote works. As far as printing calculators and stuff like that, printing out the wages, and it does. So that's a nifty little joint to have at my disposal. Like, I know it always works now. All right.
I'm going to save that. Now, I'm going to run it now. I'm going to run it now, and you'll notice something real quick. This line never came out. And that's because the way this works is this simply defines the function, and then it continues running, but it doesn't run that code. And it ran this code, and then it did, in this case, the else code, and then it did the print. But it never came up and actually ran this code. We have to call the function. Okay, we have to call the function before it's going to actually run. So now let's make a call. Compute pay, and let's pass in our variables that we have in this main code, FH and FR. So that compute pay FH and FR, and then I'm going to print out hours and rate. So now you'll see it's going to do the input, convert to floating, call the function, which is going to run this one line, and then continue down here. Right? So now what it's going to do is going to define it, run this, call compute pay, which is going to temporarily suspend, come in here, run this code, and FH is going to map to hours, and FR is going to map to rate, and then it's going to come back, and then it's going to continue down here, running this code and then finishing. Okay, so that's what's going to run. So this time we will see compute pay, and we will see the number for hours and rate. So I'll run it again. 40 hours, $10 an hour. Ah, we see a mistake. I'm like, and then you're going to see the word compute pay here. And I'm like, okay, that didn't happen. Well, what's going wrong? Let's take a look at what's going wrong. I don't plan to make these mistakes. I just make them. Let me show you what's wrong here. See this little blue dot? That's what's wrong with my code. And if you don't catch that, then you'll say, oh, I'm crazy. Well, I'm not crazy. I just made a mistake. I forgot to save it. File save or Command S. So now I saved it. I didn't change a single line of code. It was right. I forgot to save it. So I'm going to run it again now. 40 hours, $10. And look, now I see this line. So it came into compute pay and then came back and then finished this part and did compute pay. Okay? Now, this isn't enough. What I need to do is I need to move this code, the actual pay computation. So I'm going to cut that, and I'm going to put it in here. But now this variable FH belongs to the main program. It doesn't belong to this code. Now I don't want to use that. So I want to say hours. So I'm taking whatever hours are being passed in, and then using rate. And I'm just kind of changing all of these to match the parameters inside the function. This is hours, and this is rate.
I'm coming to you.
And this is hours, and this is rate. Now I'm going to print a print statement inside. I'm going to say returning, and then I'm going to print XP. And then, still inside the function, I want to return a value from this function. So I'm saying the returned value for this function is actually in the current function variable XP. And then I'm going to call, actually I'm going to not call this XP, I'm going to call this pay in here. Oops, not with capital. I don't want to be capitalized. Pay and pay and pay. So it's returning pay, and then in here I'm going to say XP equals compute pay. So what we've achieved here is, let me get rid of that. What we've achieved here is it's going to come down, define a function, then read the input, convert it to floating point, and then call compute pay, passing in FH as hours and FR as rate, right? And then it's going to take hours and rate, do whatever it does with the if then else. It's going to print these things, then it's going to return it, and then whatever this pay variable is effectively goes back into this expression as the return value, and again gets assigned into XP. Okay? So that's basically what's going to happen, and then we'll print, it'll come back and then print XP. Okay?
Let me see.
So let's go ahead and run. Oh wait, I almost did it again. Look at the little blue dot. You guys can watch the blue dot. And when I forget to save it, and when I then run it, it'll blow up. So $10 an hour, oops, 10 hours, $15 an hour. So now it worked. So you can see these two print statements come from while this is running. The input happens, it calls the function, and then it prints out the pay. And now to finish this, to get it right, I will simply comment out my little helpful debugging print statements and run it one more time, 40 hours, $10 an hour, and run it again and have it be $50 an hour and 50 hours and $10 an hour, so 550. So that one is now working. So that one is completed, and we have moved our computation inside of the function. So I hope that you find this useful. I hope that you find this entire course useful, and
I am.
And thanks for watching.
All right. You know what? I'm mildly satisfied with this. We're going to take what we can. We're going to run with it. But I appreciate you guys being here for this short little class. You know, it's cool. 2 hours. Yeah, just about 2 hours, so that was good. We'll pick up on that commute, and we'll probably be back on later on tonight, too. All right? Y'all take care of yourselves. I don't know if my credits work. Let's find out.